Hello everyone, welcome to BGP load balancing or load sharing with dual home and multi-home environment part 2. In today's section, we will be discussing how we can perform the load sharing in multi-home environment. Those who were not the part of the last discussion, I'll just give a brief overview. So the objective of this class was to discuss the difference between dual home and multi-home environment, and how can we perform the load balancing with BGP, and in which case it is not possible, how to perform the load sharing, how BGP path attributes, and then we have demonstrated how to perform load balancing, and now today we will be demonstrating how to perform the load sharing. So just to give again a brief overview. So what is the difference between dual home and multi-home environment? Dual home environment is the one in which there are two redundant links coming towards your office from a same ISP, two or more redundant links coming to your office from the same ISP. Whereas in multi-home, you will be having links from different ISP. So in dual home, you have you have the link coming from the same AS, whereas in multi-home you have the links coming from the two different AS. So load balancing is possible in dual home environment, but it is not possible in multi-home environment. And in order to perform the load balancing, we have to do load sharing in multi-home environment, in which if we have two links coming, two links coming, and we are learning a couple of subnet from both the links, then we will make one link primary for some subnet and other link primary for other subnet. So we also discussed about BGP path attribute. So there are around 13 BGP path attributes, and in order for a path to be eligible for load balancing, those paths should have first 6 BGP attributes same. Means if you have two paths towards the same subnet, and if in order for them to become eligible for load balancing, it should have weight, local preference, originate, AS path, origin, and MED same. Then only load balancing can be performed. But again, load balancing can only be performed in case of dual home environment, but in multi-home environment we can't perform load balancing, we can do load sharing. So for dual home environment, we discussed about an environment where we are having R1 at our office, R4 remote site, and R2 and R3 were ISP router. So there was single ISP. R1 is at AS 6500, R2 and R3 are AS 6501, and R4 6503. So just to demonstrate, this was the configuration. So R1 is having neighborship with R2 and R3, both are in remote AS 6501. Similarly, R2 is having neighborship with R1 and R4. R1 in remote AS 6500, that is office, and R4 is remote AS 6503, that is our remote site. Similarly, R3 having the neighborship with R1 and R4. Similarly, R4 is having neighborship with R2 and R3. Both are in remote AS 6501, and it was advertising two subnets. So what we can see on our R1 is that we are receiving two subnets from two different paths, and though without any maximum path configuration, what we can see is that BGP is only using one particular path, it is not using the other part. So in order to perform the load balancing in this particular scenario, what we have to do is, as you know, all the attributes are same, so what we can do is we can configure the maximum path under BGP, then it will perform the load balancing. So just to demonstrate it, the command for this is maximum path. So we can have up to 16 maximum equal cost path. So we'll just do it 2 for now. Now if we see the show IP route, see, now it is load balancing this particular subnet from 2 links. Similarly this one, and if I run show IP BGP, why we were able to load balance? Because these attributes were same. But this is only possible with dual home environment where we are having the link from the same AS. But in case of multi-home environment where we have the link coming from to different AS, load balancing is not possible. We are going to discuss the same. So the scenario that we will be discussing today is this. The scenario is almost same. The difference is that previously R2 and R3 were in same AS. Now R2 is in AS 6501 and R3 is in 6502. So we are just assuming that R2 is an ISP router from level 3 and R3 is an ISP router from level 2. Vodafone. Whereas R1 is again the office router and R4 is again the remote site router, and R4 is advertising two subnets. So we'll just quickly make the configuration change. So now on R2 we have to change the AS number of R3. So here's the configuration that we will be using today. So in the R1 we will be using this configuration. So let me just clear the old configuration. Now we'll simply do let me also clear the configuration on R3. Rest on R2 and R4 the configuration will remain same. Previously R2 and R1 were on AS 6501 itself, as R2 and R3 were a part of same ISP, but now they are different ISP. So we have to put R3 under AS 6502. So we'll simply do the R1 configuration first. So this is our R1 configuration. We are having two neighbor 1.2 that is connecting to the R2, and the remote AS of R2 is 6501. 2.2 that is connecting to R3 and the remote AS is 6502. R2 configuration is same as previously discussed. It is having one link to connecting to R1 at 6500 AS and other link connected to R4 at 6503. Similarly for R3 we have to again make the changes, as R3 was in 6501 previously, but now it will be in AS 6502. So let's verify if the neighborship is up now. So this is stuck in active state. Might be some mistake in the configuration. Okay, now it's up. Okay, similarly we have to make like, see, we are not getting the any prefix from R3, as we haven't made changes on R4. Previously R4 was having neighborship with R2 and R3, but both were in AS 6501, but now we have put R3 in AS 6502, so we have to make this change here. Okay, we will just say no neighbor 192.168.3.1 remote AS 6501. Okay, now Okay, I'm sorry. 3.1 was R2. So this again we have to run. We have to make the changes to 4.1. That is R3. Now this is done. Now we'll just simply change the AS number for R3. That will be 302. Now let's check if the neighborship is up or not between R4 and R3. It's not coming up. We'll check the configuration. Okay, now it's up. So now the neighborship is up. So we should see both the neighbors here. So now we are, it will take some time. Still we are not receiving any prefix from R3. Let's see. Okay. Here we are receiving prefix from here. So should be here as well. Okay, now it's fine. So now if we check, see, now again we are having two networks being advertised from two different connection, from two different link, but the difference is previously we were having two different link from same AS, but now we are having two different subnet, like two subnet from different AS. So previously, when we did a maximum path command, we were able to load balance the traffic, but now it will not work. Let me show you. So as of now, load balancing is not happening. Even if we run maximum path command, see, even after running the maximum command, there is no load balancing happening. Why? Because load balancing with BGP is not possible in a multi-home environment where we are receiving the subnet from two different AS. So in this case, what we can do load sharing. So we'll just demonstrate it. Let me just remove that maximum path command. So in order to perform the load sharing, what we will be doing is, so this is the scenario we will be discussing today. R1 connecting to two different ISPs, R2 and R3. Label 3 is the ISP1, which is having AS6501. Vodafone is the ISP2, is under AS6502. R4 is advertising two subnets, 1.1.1.1, 2.2.2.2. So what we will be doing, as load balancing is not possible and we are getting two different subnet from two links, that is coming one coming from R2 and another one coming from R3. So what we will do, we will use the path attribute to manipulate the path in such a way that for 1.1.1.1 subnet we will be using this link R1 to R2 and R4, and we will make this as primary and the other one will be as secondary. Similarly for 2.2.2, R1 R2 path link will be secondary and R1 R3 path will be primary. So we will be using the local preference. We will set local preference of this link for 1.1.1 to 110, and for this link, and for 2.2.2 we will set the local preference of this link to 90, whereas For 2.2.2 we will set local preference of this link to 110, whereas for of 1.1.1 we will set the local preference of this link to 90. So what we are going to do over here is, for 1.1.1.1, for this one we will making this link as primary and this link as secondary by setting the local preference 110 for this here and 90 here. Similarly for 2.2.2, what we will be doing, we will making this as primary by setting the local preference 1110 and this is secondary by setting the local AS of 90. We will be using route map for that. So the configuration that we will be doing is, so we will be doing the configuration on R1 end because we are manipulating the outbound routes. So for outbound routes we can either use local preference or wait. So for now we will be using local preference. So we already have the configuration done for route maps. Let me just show you. So on R1 what we have done is we have configured two access list. One is for 1.1.1, other one is for 2.2.2. And what we have done for R2, we have made a route map in which we have set the local preference 1110 for 1.1.1 subnet and local preference 90 for 2.2 subnet. Similarly for R3 we have set the local preference 90 for 1.1.1 subnet and local preference 110 for 2.2.2 subnet. So we have this configuration in place. So we are having two access list, 1.1.1 allowing this host and 2.2.2 allowing this host. These are called under route map. So we are having a route map. One is for R3 in which we have set the local preference for this host to 90 and for this host to 110. And we again have one route map for R2 in which we have set the local preference for 1.1.1 to 110 and 2.2.2 to 90. So this is what we are going to do. For 1.1.1 this will be 110 and this will be 90, and for 2.2.2 this will be 90 and this will be 110. So we already have the route map in place. Now what we have to do is we have to simply apply this route map to the BGP. So we'll go router BGP 6500 neighbor. R2 is 192.168 1.1.2 and we are going to apply route map. Route map name is this one. This is our route map, and as it is for outbound traffic, so this will be in, right? And similarly for R3 we will apply this R3. Now in order to these changes take place, we have to restart the BGP. So it will take some time for BGP neighborship to come up. So it's not getting any prefix. So now it's not into prefix. So we check. See, now as we desired for 1.1.1, R2 is primary as we have set local preference to 1110, and R3 is secondary with local preference 90. Similarly for 2.2.2, R1 is secondary with local preference 90 and R3 R2 is secondary with local preference 90, and R3 is primary with local preference 110. So what we have done, we were having two links, one coming from R2 and one coming from R3. So for 1.1.1.1 we have set a local preference of 110 for the link coming from R2, and for 1.1.1 for link coming from R3 we have set the local preference 90. Similarly, vice versa, we have set for 2.2.2 we have set 1110 local preference for link coming from R3. So now the traffic will be shared between two links. So just to demonstrate it, if we just do a trace route to 1.1.1.1, see it is using 1.2, and if we use 2.2. Now it's using 2.2. So with multi-home environment, as the load balancing is not possible, so we can use the path attribute to share the load between different links coming from the ISP. This is how we perform the load sharing. If you have any query regarding it, please post it in comment section. I will be more than happy to answer your queries. And if you want to go through our last video in which we discuss more about load balancing and path attribute, I'll just post the link of last video in the comment section. Please do subscribe to my channel so that you will keep receiving the notification of more videos. And if you like it, then please hit a like button. Thank you.